right, we're doing more AP review. This is 2006 AB Free Response 6. All right, we are given, so there's a twice differentiable function f, and it's defined for all real numbers and satisfies the following conditions. F of 0 is 2, f prime of 0 is -4, and f double prime of 0 is 3. In part A, we are given that the function g is defined by g of x equals e to the ax plus f of x for all real numbers, where a is a constant. Find g prime of 0 and g double prime of 0 in terms of a. Show the work that leads to your answer. So this is essentially testing your knowledge of the chain rule. So my g prime, right, so my g prime of x, since this is just a sum, right, I'm going to derive e to the ax. Well, the derivative of e to the stuff is e to the stuff times the derivative of the stuff. So it's going to be e to the ax times a. Plus, the derivative of f of x is f prime of x. That means that if I want to go ahead and find g prime of 0, I'm going to get e to the 0, because a times 0 would be 0, times a, plus whatever f prime of 0 is. Well, e to the 0 is 1, so I just get an a, plus f prime of 0 is a -4. So I get that g prime of 0 is an a minus 4. Cool. Okay. Let's go ahead and take my g prime. So if I want g double prime, right? So a is just a coefficient in this situation. It's not a variable. So when I want to derive a times e to the ax, it's just an a, e to the ax, times another a, because again, of that chain rule, right? The derivative of e to the stuff is e to the stuff times the derivative of the stuff. Plus, when I derive my f prime, I get an f double prime of x. So my g double prime of 0 should be an a squared e to the 0 plus an f double prime of 0, which I'm pretty sure is an a squared plus a 3. So g double prime of 0 is an a squared plus 3. This is one of those problems that the actual skill set's not really difficult. It's just a little bit different from something that you've seen and can make you feel a little uncomfortable. So that was worth 4 points. So the 4 points that we get for that, we got 1 point for finding g prime. We got 1 point for using it at 0. We got 1 point for finding g double prime. We got 1 point for using it at 0. All right, cool. Part B. The function h. Ooh, new function. So the function h is defined as h of x equals kx times f of x. We're going to have some product rule action here. So in B, h of x is the cosine of the quantity kx times an f of x, right? The f of x is not inside the cosine, but it's multiplied. Where k is a constant, find h prime of x and write an equation for the line tangent to h at x equals 0. Okay, so this is a function of x times another function of x. That's a product rule, right? So my h prime of x is going to be u, cosine of the quantity kx, dv, which is going to be f prime of x, plus v, which is just f of x, du. Derivative of cosine is negative sine, right? So negative sine of kx times the derivative of the stuff inside the sine, which is a k. Sorry, I ran out of space there for you. Okay, cool. So that's not wrong, right? This is correct for h prime, and I would argue that the AP is going to give you credit for it because they just said find h prime, and that is correct, right? If you want to make it nicer, great. If you don't, great. Remember, there's not a huge incentive to make things nicer because you risk doing something dumb. We've all been there. But if you want to try and make it nicer, you would probably make this an f prime of x in front of the cosine of kx, right? Cosine of that quantity. And then I'd probably move the negative and the k to the front and make this a negative k times f of x times the sine of kx. So if you wanted to make it nicer, it would probably look like this. But again, there's not a huge reason to make it look nicer. They just want the right answer, and that first answer was the right answer. That was the first skill, right? That's the first thing I was asked to do, and you get 2 points for it because frequently they will give you 2 points for a product rule because they're nice. Next, I need the equation of a tangent line, right? So anytime I need an equation of a line, I need 2 things, right? I need a point, which I know is 0, h of 0. I don't know h of 0 yet, but I can find it. And I need a slope, which I know in this case should be h prime of 0. So I can find both of these things based on the information I have. So I'm going to go ahead and find the point first. My point, h of 0, should be this equation with 0 plugged in. So cosine of 0 times f of 0. Well, I know cosine of 0 is 1 because my unit circle knowledge is on point, right? And I know that f of 0 is a 2. So it seems to me that my y value is a 2, right? So y value is a 2. Second thing I need is the slope. To find my slope, I'm going to do h prime of 0, which is plugging into this ugly monstrosity, so that's f prime of 0 times the cosine of 0 minus whatever k is, which could be problematic, except it won't be, because guess what? I'm going to get a sine of 0, and based on my unit circle knowledge, that whole thing gets knocked out, right? That's all a 0, because it's k times 2 times 0, so I don't even care what k is. And so my f prime is a negative 4, and my cosine of 0 is a 1, so I get that my slope is a negative 4. Once I know that, I can go ahead and put my answer as y minus the y value, which in this case is 2, equals my slope, negative 4, x minus 0. Now, the answer's fine unless they asked me to solve for y. So, they said they did not say solve for y, so that answer is totally fine. If you want to play it safe, you can add the 2 over. If I were you, I would still leave the quantity x minus 0 in parentheses and not risk making a mistake. The AP's answer is also going to accept negative 4x plus 2, because that's also right. Cool.